All right, we are back. Algebra 1, we are in section 1.7, which is functions. So we're going to learn whether a relation is a function or not, and then we're going to find the values of functions. That's our objective today. So what is a function? What is a function? That's what I want to know, is what a function is. Why is it not doing this? Come on. Oh, there it is. Okay, relationship between the input and output, independent and dependent variables. Remember those from the last lesson. And then each element of the domain is paired exactly with exactly one element of the range. So the key phrase here is it's exactly one element of the range. So each domain gets paired with exactly one element of the range. So sometimes that's confusing. So another way to think about that is that you can't repeat the x values. Can't repeat your x values. But you could repeat the y values. So you can't have two x's that are the same, but you can have two y's that are the same. Maybe two x's, two different x's, end up getting you the same y value. That happens quite a bit. That's okay, but you can have two x values that are the same. So that's one way to think about it, pairing the domain with exactly one element of the range. So next up, let's take a look at some practice problems here and determine. We're going to look at all of our ways in which we look at a relation, a mapping, a table, a graph, or an ordered pair, and decide whether it's a function or not. So this first one here, is this a function? Number one, this mapping, is this a function on this case? Well, each element in the x maps to a element in the range, in the y. So in this case, and if you look at the x values here, this is your x, this is your y. Remember, looking at the x values, we do not have any repeats in the x's. So this would be yes, it's a function. And what's our reasoning? Because it does say explain, so our reasoning would be that there's no repeats in x. No repeats in x. Okay? So if we look at number 2, you're just looking at this table here, you can notice that we've got a 2 here and a 2 here. So these are the same number. So we have repeats. So this would be not a function. And the reason is we have repeats in x. Repeats in x. Because if you were to make these as ordered pairs, you'd have an ordered pair 2, 5 and 2, 4. Well, that's impossible. And you have repeats in x. How can this 2 give you two different answers? So it's not a function because there's repeats in x. So that's one way to look at it. Ordered pairs, we just kind of talked about. If there's the same x value, then it would be if you have more than one of the same value for x's, it'd not be a function. Okay, let's look at number 4, and we've got y equals 5x minus 2. Now the interesting thing here is we can say, hey, it's written in, and maybe you've seen this or not, y equals mx plus b form. And if it's written in that form, well, then it is a function. So yes, this would be yes, a function. And why is it a function? Because you can write it in y equals mx plus b form. And it's already in that form for us. So because we know that that form gives us what's called a linear equation. So if we graph this, you'd get a line something like this. And so it's a straight line, linear function. So it's a function. Okay. Looking at number 6 with the graph, we're looking at these graphs here. And if we gave these ordered pairs, if we just kind of wrote out what these pairs would be, this one here would be -3, -1. We'd have -3, -3. And then we'd have -3, -5. And then these over here, we would have 0, 3, 2, 3, and 4, 3 for these points. Okay, so looking at this, we already know right away that we've got the same x value in these 3 points, -3, -3, -3. So this one would not be a function. Not a function. And what's our reasoning? Because we have to explain, our reasoning is there's repeats in x values. Okay? So hopefully we get the idea of that. Vertical line test. It's another way in which we can test to see if it's a function or not using the graph. So if a vertical line can be drawn and it touches the graph in only one point at a time, then we can say that that relation is a function. So I want to try to get us a vertical line, and let's use this. Okay, let's see what we can do here. All right, perfect. Use a purple line here. All right, so I'm going to take this purple vertical line, and I'm just going to run it over the graph and see if it's a function by using the vertical line test. So you could just draw one, but if you take a look as I run this over the line, here it is. It only touches that graph in one point the whole way through it. It's only touching at one point. Every time I move it horizontally across, the vertical line only touches in one point. So this one would be a function. Okay? So we would say this is a function. And what's our reasoning? Our reasoning is it passes the vertical line test. Okay, so let's check the next one and see if it passes the test. So I bring this line over, and it's only crossing one point here, but as it's right here, we've got it crossing 2 points. As you can see, it crosses right here and right here. So that would be not a function because it doesn't pass the vertical line test. Because you'd see we'd have 2 x values. If you gave these coordinate points, you'd have an x value the same here and an x value the same here. So you'd have 2 x's, which you can't have. But we can just simply put does not pass vertical line test. All right, the third one is an interesting one. Okay, because as you can see from this point here, it passes the it passes the vertical line test on the left side because it only touches the line once. But on the right side over here, it also passes because it only touches the line once. The tricky one is right here in the middle, right here in the middle, because it looks like it touches it twice. But we have to point out a couple things. Number one, that this is an open circle. It's an open circle. And what does it mean if it's an open circle? So what it means if it's an open circle is that this graph includes every value except for exactly that point. So it would not necessarily include this point where it's at because it's an open circle. Where this one is a closed circle, so that says this graph includes everything including that point. So technically this is a function. Because of that open circle, it crosses the graph here, but it technically would not cross there because it's an open circle. So this one would be a function. And we could say, again, passes the vertical line test. Simple as that. Okay, so hopefully we're good with the vertical line. All right, next up. Function notation. So we look at our table over here to the right, and really this is just a fancy way of writing the equation down. So first thing, it's just a fancy way to name a function. And we read it as f of x. So you've got this equation, y equals 3x minus 8. Instead of saying y, we say f of x equals 3x minus 8. Nothing really changes about it. All we're really doing is you're taking the y here and replacing it with the f of x. It's just, like I said, a fancy way to read it. But the f means function, so you're doing the same thing. You're substituting values in. So we just kind of replaces, excuse me there, just replaces the y with an f of x. Okay, so, and sometimes even they get fancier and they have a graph here, and we're going to have what they might do. You might see this from time to time when they get extremely fancy, is they make this the x value, and then they make this the f of x value. Or excuse me, the axis. So you have the x-axis here, and then this would be the f of x axis instead of the y-axis. Doesn't do anything. It's just another way of saying the y. Now you could actually find a solution here as well, because if you just say plugged in, let's say if x equals 2, all you're really doing is you're going to substitute that 2 in for everywhere you see an x. So the same with the equation, you'd plug in that 2 here. Same with the function. You're just going to plug that 2 in everywhere you see an x. And then you can find a solution. All right, function values. So what we're doing here is we're substituting a value in for x in the equation, and then we're simplifying. I'm just going to simplify that. Okay, so let's look at the practice problems down here. What we're looking at in practice problem A is we've got f of negative 2. So all we're going to do is we're just going to sub in that number, negative 2 into everywhere we see an x. So when we write this, we're going to say this is the negative 2. We're just kind of plugging it in all those x's. And so when I write this, instead of writing y, I'm writing f of negative 2 equals 2 times negative 2, because I'm just substituting it in for that x, plus 5. Now when we do the math, we're going to end up getting a negative 4 here, plus 5. And so basically, we just do that math across, negative 4 plus 5, and we get f of negative 2 equals 1. And that would be our answer there. Okay. Looking at example B is a little bit tricky because we've got the f of 1 plus 4. Now, I've got to point out that this plus 4 is not in the parentheses. So when we plug in our 1, we're only plugging it into where the variable is. You could save that 4 for later. Okay, so when we do this one, we're going to go f of 1 equals 2 times 1, because I'm substituting that in for x, plus 5. And I'm just going to save that 4 for the very end. I'm just going to highlight it here so I remember that it's there. Okay, so we can't forget about it. And now I'm just going to continue doing the math here. So f of 1 equals, well, 2 times 1 we know is 2, plus 5 is 7. So f of 1 is actually going to be 7 here. But now we have to continue to add that 4 to our final answer. So when we go f of 1 plus 4, and again, that 4 is not in the parentheses, we get 7 plus 4, which is 11. Okay? And letter C is the best example here because now you notice that the x plus 3 is actually all in the parentheses. Okay? So when we do this problem, we're going to have x, or f of x plus 3 is going to be equal to, we've got that 2, and now substituting, we've got to plug this whole thing in for x. It's got to all sub in for us. So now it's going to be 2 times x plus 3, and we still have that plus 5 at the end of the function. Okay? So now doing this math, of course, now we have just about simplifying. It's the same thing. We just got to simplify by using the distributive property. So I'm going to go 2 times x and 2 times 3. So 2 times x I know is 2x. 2 times 3 I know is 6, plus 5. So now I've just got combined like terms here. I've got one set. There's no other 2x's, but I can combine this 6 and this 5. And so my final answer here would be f of x plus 3 would equal 2x plus 11, because it's just about simplifying that now. And that would be my solution there. Okay, so just finding the values, and just again, be careful with those parentheses. All right, let's move on to this next couple problems. And this one, nothing really changes here. Just want to point out that it's if h of z here. So it's just a different way of saying f of x. Sometimes if you have more than one function, they might call one f, one g, one h, and so on. So there's just different letters. So notice z is in parentheses, so that's the one that we're going to substitute in for. So this one just says h of negative 4. So h of z equals z squared plus 3z minus 4. All right, so again, we're just looking at the z values because that's what we're going to plug in. So this negative 4 is going to go in here and it's going to go in here. We can't forget both spots. All right, so h of negative 4. So when we do this one, we're going to end up with, well, it's z squared, so negative 4 squared. And I'm putting it in parentheses for a reason because we're substituting it in. You got to substitute the negative 4 in, plus 3 times z, which is a negative 4, again, substituting that in, minus 4. So we got a lot of 4's going on. So now let's go ahead and do some math here. Negative 4 squared gives us 16 because negative 4 times negative 4 is a positive 16. If you punch it into your calculator and you got a negative 16 there, you have to do it again and put the negative 4 in parentheses. And then over here we've got a negative 3 a positive 3 times a negative 4, which is a negative 12. So you can write it plus negative 12. Okay, it's the same thing as subtraction. Remember, subtraction is the same as adding a negative, or you can write it like this. And then we add that minus 4 there. So now, order of operations, we're just subtracting. We go left to right. We should get an answer here of 0 for h is negative 4, h of negative 4, 0, because 16 minus 12 is 4, and 4 minus 4 is 0. Okay, and you guys can work on letter B on your own. Okay, real quick here, we're just going to go through these pretty fast. We don't have to worry about memorizing these too much. We just want to touch on them. But discrete function, continuous function, nonlinear function. Discrete function is a function with a graph that's a straight line. Continuous function is a graph with a straight line or a smooth curve. And it's not all broken up. And then a nonlinear function is a graph that consists of points that are not connected. Well, they could be connected. Could be connected. So we'll just make sure that we say they're not straight. Not straight. Okay? And again, don't worry too much about those, just some terms we'd like to know. Our lesson summary here, if given a set of ordered pairs, how can you tell if they are a function or not? Should be able to answer that question. And then the practice problem here, make a mapping for the relation with those points. Is it a function? So what we're going to do here is you're actually going to make a map like we did in our last lesson. We got an x values here and y values here. And remember, we should try to have numbers mapped across. And if it's a function, there's certain reasons why or why not. So answer those questions. Okay, that is section 1.7 for you. And I think we're closing in on the end of the chapter. So we'll be ready to review and test. So bring your questions, and we'll get to work on this tomorrow.